This is problem 72 of Neetcode 150, subset 2. So we are given an array of integers, and this array might contain duplicates. Our goal is to return all the possible subsets that we can do with this input, but we can't have duplicates. So this is something that we are going to have to account for. So for example, here we can have 1 and 2, right? But we could technically, by taking each value one by one, we could eventually have this 2 and this 1, which will give the exact same subset 2 and 1, right? The same two values, but this is something we want to avoid, right? So our answer has to be, well, one possible answer, it's an empty array, another one is an array with only a 1, another one's an array with a 1 and a 2, another one's an array with the 2 1s. You can have the array with only 2, or you can have the array with all the numbers. Okay, so let's see how we can actually do this. So let's say that we have this array with the 1, a 2, a 2, a 2, a 3, and a 4. So first of all, we're going to use backtracking, so a depth first search algorithm. And basically, initially, you want to add the 1. And once we had the 1, we have the choice of either adding this other the next numbers, or a 2, or we can refrain from adding the 2, so it will just stay at 1. And then from this we could let me just move this. All right, so from this point you can either decide to add the 2 again, so you will have 1, 2, 2, or you can also decide not to add the 2, so you will have 1 and 2. But notice all right here, well, in this position, this is where we decide to skip the first 2, but now we have a third 2, so we can actually decide on adding this 2 or not adding this 2. But notice that these 2 are exactly the same. So what we are going to have to do is basically, once we add the next value, right, this is okay. I mean, we want to have in our answers an array that contains basically the 1 and the 2, 3. So we want to have this. We also want to have an array that contains 1 and 2, 2. But when we are on this specific side, like where we decide not to add the 2 at first, well, we want to make sure that we actually run we want to use a while loop. So since we decided not to add the 2, we're going to let that left branch actually go through all the 2 possibilities. And for this right branch, what we're going to do is basically we're just going to check if that next value here, so excuse me for that, we're just going to check if that next value here is actually the same. If it is, we're just going to move our pointer, and we're going to do that until we find something that is not what we used to have to. So notice that here we will have 1 and 3, or we just don't have 3, okay? And that's the logic actually. So we can start coding this. So first, what do we need? We are going to have to create an array where we're going to append all the possible combinations. And what you want to do, notice that in my example here, the array is actually sorted, because this is the best way to do it, as we can easily see if the next neighbor is the same. Otherwise, it will be quite messy. Like, how do we check if we have duplicates, right? So when we sort it, we can just see if the next value is the same. If it is not the same, and we know it is sorted, we know it is going to be greater. So we don't have to actually get some headache by creating a hash map to keep track of all the values. So let's simply sort this. So we're going to say nums that sort. All right, and now we're going to create our backtrack function. So let me just call this depth first search, because this is basically the algorithm that we use for backtracking. And you want to pass basically an index and a subset in it. You'll see why. So at the end, when we call the function, we're going to just say pfs, and we're going to start at index 0, and we are going to give them an empty array. and then we are going to return the results. Okay. So now it is our time to create the logic of the depth first search function. First of all, our logic is that if we reach an index that is out of bound, it means that we went through every single values, and our pointer actually went through all the values. So we did all the combinations, so we can actually append the subset that we had at this instance to the results, and then return our recursive call. So we're gonna save this way. So if I is equal to the length of nums, well, it must mean that we are at an index that is out of bounds. So we're gonna just say res that append, and we are gonna append to it basically the subset that we have, and we have to make sure that we create a copy. So you either say dot copy like this, or you can simply call it this way. It's all you prefer. All right, and once you do that, you're going to be willing to return your recursive call. All right, so now that this is done, in our example, we have to create what the left branch is and what the right branch is. Well, we know that the left branches is only the branch that will just take the next index and append it to the subset. So we're exactly going to do that. We're going to take our subset and we're going to append to it the nums at the index I. Right? And to continue this recursive call, we're just going to call again DFS, and we're going to go see the very next element. So I plus 1, and we're going to pass the subset, so that we're going to go take the next index every single time. And we're also going to have to be accountable for the case, like in our example where we had 3 times the value 2, right? So in this example, we want to make sure that we don't take it 2 anymore. So we go see the next value, in our case 3. So what we're going to do is that we are going to pop the value that we just appended to it right here. And we are going to go see what is the next value. So we don't get duplicates this way. So we're going to say subset, and we're going to pop its last value. And now this is where we're going to say basically while first if we are in range. So if I plus 1 is smaller than the length of the nums, right? Otherwise we don't want to continue. And also if the nums at the current index that we are at is the same as the num at the index 1 further. So while both statements are true, what we're going to do is that we are going to move our pointer by 1, so that after that we can call our DFS with the index I plus 1. So we're going to go reach a value that is not the current value at the index I, and we're going to add to this the subset. All right, so that's the entire algorithm. If I didn't mess up anything, it should work perfectly. Let's try this out, and it worked awesome. So I hope you learned from this video, and I hope to see you in the next one.